Now we simplify this numbers. So I get 2 into 1, 2 plus 5 2s are 10. We have to do 3a minus 2b. So 3a minus 2b equals 9 minus 12. 5 minus 2 is 3 plus 1 is 4. 3 plus 2, 5 plus 1 is 6. Hello everyone, I am Purnima, faculty in the Department of Commerce and Management, Vidhyaashram First Grade College, Temple of Excellence, MYSURU. I welcome you all to this session. In this session on matrices and determinants, we will be having a look at what is a matrix and what are the various types of matrices, and we'll also be working out a few problems on matrices. Now, let us understand what is the meaning of the word matrix. So, a matrix is a rectangular array or arrangement of elements or numbers in rows and columns. So, the numbers in a matrix are called its elements. Elements may be real or complex in nature. So, we should understand that a matrix is an arrangement of numbers. So, it may be 1, 2, 3 or A, B, C, anything. So, whatever, it is an orderly arrangement of numbers in rows. So, we have this first row and the second row, and we also have 3 columns in this matrix. So, here also it may be simple or complex. So, complex numbers also can form a matrix. So, it is 1 square, 2 square, 3 square, A square, B square, C square. So, the order of the matrix is 2 into 3. Now, we should understand what is the meaning of 2 into 3. So, this means first this is 1 row, that means 2 rows. 2 by 3 is the order of the matrix. So, 2 stands for number of rows, 3 stands for number of columns. So, here 1, 2, 3. So, 3 columns. So, this is the order of the matrix. So, whenever we talk of matrices, it will always be represented by a capital letter, and it will have in between, it will always be written in between 2 brackets, and it will have the order of the matrix written on the side of the matrix. So, a matrix is an arrangement of numbers. So, it may be simple numbers or complex numbers or anything. It need not be numbers only. It can be alphabets also. Then the order of the matrix will be written here, and it will be represented by a capital sign, and it will be always between 2 brackets. Next. Order of a matrix. The number of rows in a matrix is denoted with M, and the number of columns is denoted with N. Hence, the matrix can be called as M by N. Here, M and N are called dimension of the matrix or order of the matrix. Now, rows of the matrix are denoted by M and columns are denoted by N. So, M into N means rows into columns. So, we should understand that the order of a matrix denotes the rows and columns. First always will be the count of rows and second will be the count of columns. Then the next type of matrix is a square matrix. So, square matrix, when both M and N are equal, it is called as a square matrix. So, the number of rows should be equal to the number of columns. If you can observe here, in this matrix we have 2 rows, 2 columns. In this matrix we have 3 rows, 1, 2, 3 and 3 columns, 1, 2, 3. So, when the M equals N, we call it as a square matrix. Next one. Row matrix. It is a matrix where there is only one row and any number of columns. Now, if A equals 1, 2, 3, 4. See, if A equals 1, 2, 3, 4, then there is only one row. And how many columns do we have? 1, 2, 3, 4. 4 columns. So, any matrix with only one row and many columns, we call it as a row matrix. the next one is a column matrix. So it is a matrix where there is only one column and any number of rows. Suppose I write A, B, C, D, E. So it is a matrix where there are many rows. How many? 1, 2, 3, 4, 5. So 5 into 1. So this is the order of the matrix. Why? There are 5 rows and only 1 column. Here if you can see 3 rows, 1 column. Here there are 4 rows, 1 column. So we should understand that any matrix with only 1 column, we call it as a column matrix. Then next one is diagonal matrix. So it is a square matrix in which all the elements except those in the leading diagonal are 0. So it should be a square matrix. So if I write 1, 2, 3. So it should be a square matrix in which all the elements except those on the leading diagonal are 0. So that means other than the diagonal elements, all elements are 0. So I can write it like this. So if you can see here, A equals 2, 0, 0, 0, 3, 0, 0, 0, 4. So the diagonal elements are 2, 3 and 4. If you can see here, 5, 0, 0, 7, only 5 and 7 are the numbers. And here, if you can see matrix C here, 1, 0, 0, 0, 2, 0, 0, 0, 3. So all these are zeros, whereas only the principal diagonal elements are in numbers. We call those matrices as the diagonal matrix. Then next one is unity or identity matrix. So A equals 1, 0, 0, 1. So here again, if we can have all the elements of the diagonal as 1, then we call it as the unit or the identity. So 1, 0, 0, 0, 1, 0, 0, 0, 1. So all these are in 1, 1, 1. So we call it as the identity matrix. So all elements should be 0, only the diagonal element is 1. The next one is the scalar matrix. It's a matrix in which all the diagonal elements are equal. So here if you can see here, the diagonal elements are 4 and we can find only 4 there. Here if you can see the diagonal elements are 3, we don't have any other numbers, then it is a scalar matrix. Now I can write one more. So if I write 5, 0, 0, 0, 5, 0, 0, 0, 5. Then this also becomes a scalar matrix. So only the diagonal element should be the same and all other elements should be 0. Then we call it as the scalar matrix. Then next one is void or 0 or the null matrix. It is a matrix where all the numbers are 0. So you don't have to bother about the order. So all numbers are 0. A equals 0, 0, 0, 0. B equals 0, 0, 0, 0, 0, 0, 0, 0, 0. So this is also a null matrix. It's also a null matrix. Now the next type of matrix is triangular matrix. So in a triangular matrix, it is a square matrix where every element above or below the leading diagonal is 0. It may be the upper triangular or the lower triangular. So here in this kind of a triangular matrix, we can find a triangle for zeros. So here this is the principal diagonal elements, that is 6, 4, 1, and then we have 3 numbers here above the principal diagonal. So that here in this we have 3 zeros. So we call it as the lower triangular matrix. Now in this B, so we have all the numbers in the lower side. In the upper side we have a triangle for zeros, that we call it as the upper triangular matrix. Now let us have operations on matrices. So in this, first one is addition of 2 matrices. So the sum of the 2 matrices of the same order is the matrix whose element is the sum of the corresponding items of the given matrix. Now, suppose if A equals 5 minus 1, 8, 9, B equals 8, 9, 8, 3, then A plus B will be, so we have to add 5 plus 8. So, 5 plus 8, then minus 1 plus 9, minus 1 plus 9, then 8 plus 8, I am writing it here, 8 plus 8, then 9 plus 3, 9 plus 3. So, 5 plus 3 is, so 5 plus 8 is 13, then minus 1 plus 9 is 8, 8 plus 8 is 16, 9 plus 3 is 12. So, in this way, we can add the matrices. Now, you can go to the next example here. So, here if you can see here, 1 minus 9. So, 1 plus minus 9. So, it becomes 1 minus 9. Then 2 minus 8. Then 3 minus 7. 4 minus 6. 5 minus 5. Then 6 minus 4. 7 plus 3. 8 plus 2. 9 plus 1. So, if we can see the matrix here, so 1 minus 9 is minus 8, then 2 minus 8 is minus 6, 3 minus 7 is minus 4. Now, 4 minus 6 is minus 2, 5 minus 5 is 0, so 6 plus 4 is 10, then 7 plus 3 is 10, 8 plus 2 is 10, 9 plus 1 is 10. If we can see here, we add the corresponding elements of the matrix, and the main condition is both the matrices should be of the same order. Only then we can have addition of matrices or subtraction of matrices. Now, in this, let us look into the subtraction of matrices. So, two matrices of the same order can be subtracted. So, if A and B are two matrices of the same order, then we have A minus B equals, subtraction also can be done in the same manner of addition of matrices. So, the way we do addition of matrices, the same way we can do subtraction of matrices. So, here if you can see here, A minus A equals 3, 6, 2. So, A minus B will be equal to 3 minus 5, 6 minus 1, then 2 minus 2, then 2 minus 6, 3 minus 4, 8 minus 3, then 6 minus 3, 4 minus 2, 5 minus 5. Now, when we simplify this, so 3 minus 5 is minus 2, 6 minus 1 is 5, 2 minus 2 is 0. Then 2 minus 6 is minus 4, 3 minus 4 is minus 1, 8 minus 3 is 5. 6 minus 3 is 3, 4 minus 2 is 2, 5 minus 5 is 0. So, this is how we will be subtracting the matrices. So, the only condition is both of them should be of the same order. Then, next, equality of matrices. Two matrices are said to be equal if and only if they have the same order and all the corresponding elements are equal. So, they should be of the same order and corresponding elements are equal. Then we can say that the matrices are equal. Now, if you can see here, A equals 1, B equals 2, then C equals minus 3, D equals 4, E equals 5 and F equals 6. So, when we have equality in these numbers, then we call it as the equality of matrices. Now, the next problem, next we see the multiplication of matrices. The given matrix can be multiplied by any constant number or any other matrix. So multiplication of matrix by any one number is called as scalar multiplication. So if A is a matrix and K is a constant, then Ka is obtained by multiplying each element of A by K. So I will explain here. Suppose we have a matrix A equals 5, 6, 8, 9, 3, 4, 1, 2, 7. Then 3A will be equal to, so 3 into 5, 6, 8, 9, 3, 4, 1, 2, 7. So 3 into 5 is 15. 3 into 6 is 18. 3 into 8 is 24. Again 3 9s are 27. 3 3s are 9. 3 4s are 12. Then 3 1s are 3. 3 2s are 6. 3 7s are 21. So we have the matrix where it is each element of the matrix is multiplied by 3. It can also be done through addition operation as A plus A plus A equals 3A. Now we can do this multiplication by adding the matrix again and again 3 times. So both are fine. Next one, multiplication of one matrix by another matrix. The product of two matrices is defined only when the number of columns of the first matrix is equal to the number of rows of the second matrix. Suppose matrix A equals 2, 5, 6, 8, 9, 0. So we have matrix A 2, 5, 2, 6, 5, 8, 9, 0 and matrix B equals 1, 2, 3, 6, 8, 1. So here the matrix order is 2 into 3. Here the matrix order is 3 into 2. So we can have a multiplication of matrices when the number of columns of the first matrix, that is the number of columns of the first matrix is equal to the number of rows of the second matrix. So if I have to multiply, I will write 2 into 1 plus 5 into 2 plus 9 into 3. Then next one will be 6 into 1 plus 8 into 2 plus 0 into 3. Now again the same process, 2 into 6 plus 5 into 8 plus 9 into 1. Now again 6 into 6 plus 8 into 8 plus 0 into 1. Now we simplify this numbers. So I get 2 into 1, 2 plus 5 2s are 10 plus 3 9s are 27. 6 1s are 6 plus 8 2s are 16 plus 0. Now here I have 12 plus 5 8s are 40 plus 9 1s are 9. 6 6s are 36 plus 64 plus 0. Now when I multiply, when I add all this, 10 plus 2 12, 12 plus 27 is 39. Then 40 plus 12 is 52. 52 plus 9 is 61. 16 plus 6 is 22. 64 plus 36 is 100. So this is the answer. So we have to do this. So we get a matrix of order 2 by 2. So whenever we have multiplication of matrices, the column of the first matrix should be equal to the row of the second matrix. Then next, Properties of matrix multiplication. Matrix multiplication is associative. If A, B and C are three matrices, then AB, BC and AB and BC are defined, then A into BC equals AB into C. So it is distributive when A into B plus C equals AB plus AC into BC, or A equals BA plus AC. So matrix multiplication in general is not commutative. So it is not commutative. The transpose of a matrix is obtained by interchanging the rows and into columns and columns into rows. Now what do we mean by transpose? Suppose I have a matrix. So A equals 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, if I want to have a transpose of this, I will write it as AT equals 1, 2, 3, 4, 5, 6, 7, 8, 9. So, I just convert the rows into columns, then I get the transpose of the matrix given. Then, next one. Let us do some problems on matrices. So, if A equals 3, 5, minus 7, 2, 6, minus 2, B equals 6, minus 3, 5, 2, minus 5, 9, then find 1, 2A plus 3B and 3A minus 2B. So, first one, let us find out 2A equals 2 into 3, 2, 5, 6, minus 7, minus 2. So, this will be equal to 2 3s are 6, 2 5s are 10, minus 2 into 7 is minus 14. Then 2 2s are 4, 2 6s are 12, 2 2s are minus 4. So, we got 2A. Now, I have to find 3B. 3B equals 3 into 6, 2, minus 3, minus 5, 5 and minus 9. Now, I multiply each element by 3. 3 6s are 18, 3 3s are 9, 3 5s are 15, 3 2s are 6, 3 5s are 15, 3 9s are 27. Now, I have to add both these. So, 2A plus 3B equals 6 plus 18, then 10 minus 9 minus 14 plus 15. Next, 4 plus 6, 12 minus 15 minus 4 minus 27. So, when I simplify this, 18 plus 6 is 24. 10 minus 9 is 1. This will be 1. 6 plus 4 is 10. Minus 3 minus 31 is the answer. So, I have 18 plus 6 is 24. 10 minus 9 is 1, minus 14 plus 15, 1, 6 plus 4 is 10, 12 minus 15 is minus 3 and minus 31. Now, we will do this. 3A minus 2B. Now, I write 3A equals 3 into 3, 5, minus 7, 2, 6, minus 2. Now, I will multiply each element by 3. So, this will be 3 3s are 9, 3 5s are 15, 3 7s are 21. Again, 3 2s are 6, 3 6s are 18, 3 2s are 6. Next, minus 2b. So, 2b equals 2 into 6, 2, minus 3, minus 5, 5 and minus 9. So, this will be equal to 2 6 are 12, 2 3s are 6, 2 5s are 10, 2 2s are 4, 2 5s are 10, 2 9s are 18. So we have these numbers. Now we have to do 3a minus 2b. So 3a minus 2b equals 9 minus 12. Then 15 minus of minus 6. Then minus 21 minus 10. Next one. 6 minus 4. 6 minus 4. 18 minus of minus 10. Minus 6 minus of minus 18. Now, when we simplify this further, we get 9 minus 12 is minus 3. 15 plus 6 is 21. Minus 21 minus 10 minus 31. 6 minus 4 is 2. 18 plus 10 is 28. Minus 6 plus 18. So this will be 12 is the answer. So when we simplify, we get minus 3, 21, minus 31, 2, 28 and 12. Now the next problem. If A equals 6, 1, minus 5, 7, minus 7, 2, 3, 1, minus 4, 2. B equals minus 2, 3, 1, 4, 3, minus 5, minus 2, 6, minus 4. Minus 1, 2, 3, 3, 5, minus 2, 5, 1, 6. Now find A plus B plus C. Now I write A plus B plus C equals 6 minus 2 minus 1. So all the corner elements I am taking. Next, 1 plus 3 plus 2 minus 5 plus 1 plus 3. Now here minus 7 plus 4 plus 3, 2 plus 3 plus 5, 3 minus 5 minus 2. Next one will be 1 minus 2 plus 5 minus 4 plus 6 plus 1, 2 minus 4 plus 6. Now we simplify this. So A plus B plus C equals, so this will be equal to 6 minus 3 will be 3, minus 7 plus 7, 0. So this will be 5 minus 2 is 3 plus 1 is 4. 3 plus 2, 5 plus 1 is 6. So 5 plus 5 is 10. 6 plus 1, 7. Minus 4 is 3. Minus 5 plus 4 minus 1. So minus 7 plus 3 minus 4. So 6 minus 4 is 2 plus 2 is 4. So this is the answer. So A plus B plus C equals 3, 6, minus 1, 0, 10, minus 4, 4, 3, 4. So this is the answer. Now we need to find out B minus A minus C. Now we write B minus A will be equal to minus 2, 3, 1, 4, 3, minus 5, minus 2, 6, minus 4. Minus A equals 6, 1, minus 5, minus 7, 2, 3, 1, minus 4, 2. So B minus A will be equal to minus 2, minus 6, 4 plus 7 minus 2 minus 1. Now 3 minus 1, then 3 minus 2, then 6 minus of minus 4 is plus 4. Then again 1 minus of minus 5, that is plus 5. Then minus 5 minus 3 minus 4 minus 2. Now we got B minus A will be equal to minus 4, 11 minus 3, 2, 1, 10. Then it will be 6 minus 8 minus 6. So B minus A we got. Now we should do A minus C. So B minus A we have. Now here B minus A is minus 4, 2, 6, 11, 1, minus 8, minus 3, 10, minus 6, minus. Now we have to subtract it from C. So C will be equal to minus 1, 2, 3, 3, 5, minus 2, 5, 5, 1, 6. Okay. So we'll subtract this. So when we subtract, we get minus 4 plus 1. Minus 4 plus 1. Then 2 minus 2. 2 minus 2. 6 minus 3. Then 11 minus 3. 1 minus 5. Minus 8 plus 2. Next will be minus 3 minus 5. 10 minus 1. Minus 6 minus 6. So when we simplify this, I get the answer as minus 3, 8, minus 8, 0, minus 4, 9, then 3, minus 6, minus 12. So this is the answer. Now the next problem, find the value of x and y equals 4 into 4 to 6, 3 into 9 and 5. So we have a matrix multiplication problem here. So this will be equal to x by y equals 4 into 9, 36, plus 6 into 5 is 30, 2 into 9, 18, plus 15. So this will be equal to 36 plus 30 is 66, 18 plus 15 equals 33. So x, y equals 66, 33. Therefore, x equals 66, y equals 33. So, this is the answer. We come to the end of this session. Thank you.